Nitration of benzene, how benzene is converted to nitrobenzene. This is another electrophilic substitution reaction where benzene is treated with HNO3 and H2SO4. This mixture is called nitrating mixture because from this mixture we get this nitro group, NO2 group, and in this way our benzene is converted to the nitrobenzene. This is called nitration of benzene. And this is the overall reaction. Now I'll discuss its mechanism. As usual, this is electrophilic substitution reaction, and step 1 is the generation of electrophile. How that electrophile is generated. So nitrating mixture, you focus on nitrating mixture. So this is nitric acid and H2SO4. Actually just like acid base reaction, nitric acid is acting as a base because it is taking that proton from the H2SO4. So the proton is taken from the H2SO4 by using this lone pair of electron. Now you can see here on this oxygen there are how many electrons? 1, 2, 3, 4, one from this bond, one from this bond. So total 6 electrons. If 6 electrons are there on oxygen, there is no charge. If 1 electron less, 1 positive charge. One electron more, 1 negative charge. Just like this. So if this proton is abstracted from sulphuric acid by using this lone pair, so you can see here this proton is now forming bond with this oxygen by using this lone pair. Just one lone pair is left over this oxygen. Now you can count number of electron on this oxygen. There are 1, 2, 3, 4 and 5. As I mentioned earlier, if there are 6 electron, no charge, 1 electron less. Just like this, 5 electrons. So positive means one formal charge is developed here on this oxygen. So if I take this proton, this bond will go here, and we get here by this bisulfide. So this anion is produced. Now what happens with these positively charged species? Now this positively charged species as early as possible will remove water, and to generate water we need to break this bond because on the oxygen we need one more lone pair. So this bond is moving on this oxygen as a lone pair, so we get here water, and if this bond pair is moving on this oxygen, so 1 electron is less on this nitrogen. So you can see on nitrogen we need 5 electrons for no charge. If 1 electron more means 4 electron, it will have positive charge, and if 1 electron more means 6 electron, a negative charge will be there on the nitrogen. Now if this bond is completely going on this oxygen as its lone pair, so 1 electron is less here on this nitrogen. So because of this there will be a positive charge, so this nutronium ion is generated like this. So to understand why that positive charge is there on this nitrogen, you have to write its Lewis structure. So its Lewis structure showing clearly that on this nitrogen 1 electron, 1 electron, 1 electron and 1 electron, there are just 4 electrons, and because of this there is a positive charge, a positive formal charge developed here on the nitrogen. So this is the structure, Lewis structure of nitronium ion, and this is electrophile because this is electron deficient species. Now second step is, as usual, is attack of an electrophile on the benzene ring because there are 6 pi electrons circulating below and above the ring. So these, now again I'm selecting this carbon, so you can join that electrophile anywhere, but you have to follow this route and remove this pi bond outside to join this nitronium ion or nitrogen. So this is the bond, this is a pi bond. After removing outside, forming bond with this nitrogen of nitronium ion. So now once that bond is formed, this nitrogen is having 5 electrons, and because of this that positive charge is vanished. So positive charge is developed here on this carbon because there are just 3 electrons from 3 bonds, and we know a carbon requires 4 electrons, and if 1 electron less, positive charge, 1 electron more, negative charge. So this carbocation is generated, and you can see my previous video, bromination of benzene, where I have clearly shown all possible resonating structure that I am not going to repeat over here. But you have to draw. You can draw 3 resonating structure by just moving pi bond which is present in between these 2 carbons, adjacent carbon, and you can shift this bond here to draw resonating structures, and in this way you can draw 3 resonating structure. So this is a counter ion, bisulfate is there, and as I mentioned earlier, the second step of electrophilic substitution reaction is a slow step because aromatic center is disturbed, and again this carbocation is generated. But this carbocation is stable because of resonance. Now final step is removal of proton. As usual, this bisulfate ion will remove this proton by providing a pair of electron, and the bond between carbon and hydrogen is now becoming a pi bond. This pair is going inside. So this is a pi bond now. Because of this aromatic center is regenerated and we get our product, and H2SO4 is formed. Now you can see here H2SO4 is consumed here and it is regenerated in the final step. So it is acting as a catalyst. So in this way, in nitrating mixture, H2SO4 is acting as a catalyst, and which is used to generate nitronium ion, which is acting as an electrophile. Thank you.